Hey guys, I'm Bowen, part of Fairblock. We'll talk about, I guess, dynamic confidentiality and leaderless auctions. Um, so I guess dynamic confidentiality sort of means we want to offer flexible sort of confidentiality solutions to users and applications um, without like sort of being constrained to one particular cryptography scheme or use case, right? What we're at Fairblock trying to do is we want to be composable, so we want to allow our sort of solutions to be plugged into any ecosystem, any EVM ecosystem, and we also want to offer multiple cryptography schemes. So there's sort of like no one-size-fits-all solution, and we plan to offer all of them, or most of them, going forward. One of the sort of problems that we've seen in the space so far is that we have a lot of cool technology. We have a lot of like big infrastructure projects, but sort of there's no real applications yet. So here we outline sort of a few interesting applications that one can build using dynamic confidentiality solutions. So things like multi-party games, prediction markets, incorporating some sort of mystery, randomness generation, joke race, and like sort of prediction market, polymarket like oracle solutions. So like UMA and UMA oracles plus encryption to prevent like collusion and collusion when voting for the oracles. The title of the talk talked about confidential auctions. So where are they used? In intense markets, traditional IPO, ICO sort of markets, pre-confirmations, MEV, RWA, sort of the list goes on. And why would we want it? There's some sort of incentive alignment, so it's effectively a sealed bid second price auction, sort of game theoretically entices you to vote for the true value that you believe in. It's leaderless, so you have no risk of front running. Or no sort of extra power granted to the person running the auction. And there's some other sort of advantages here. The demo that we sort of prepared today was built using Arbitrum Stylus. Stylus sort of allows you to have WASM sort of contracts within the EVM. And because of this, we're able to bring a lot of cryptography primitives on-chain. And as you'll see later, the entire sort of decryption process is fully done on-chain without the use of a precompile or anything like that. Yeah, and also allows you to compose with existing protocols. So for example, you can interact with Uniswap in a way by encrypting Uniswap orders. And using Stylus and our sort of libraries, you're able to decrypt the transactions and execute them. Okay, yeah, so this is a bit of like a live demo, so bear with me for a sec. Yeah, so before sort of the workshop started, I deployed a few of these decryption contracts. So one limitation of Stylus is like the size requirement of the contracts. They need to be below some number of kilobytes, and unfortunately our sort of cryptography solutions require a bit larger contracts, so we had to split them up into separate parts. So there's like a set of, I think, five or so contracts that we had to deploy individually, but there's only one that you mainly interact with, and all the other ones are called in the background. And to give a high-level overview of how like the encryption works, we use a combination of both like symmetric key encryption and then also identity-based encryption. What we do first is we encrypt the transaction data using a symmetric encryption algorithm. And then what we do is we encrypt the symmetric key with identity-based encryption. And this allows you to have arbitrary sort of conditions under which you release the key. So in this case, we have an identity that's like a Stylus workshop. That's the identity. And From that, you generate like a unique key that you can use to decrypt a set of transactions, not just one. Yeah, so we have the sort of Solidity contract here. This I decryptor or interface is what the Stylus contract is. So we call it like a decryptor contract where it takes in the ciphertext C, and then it takes in the secret key or the decryption key as well. And then it returns sort of the underlying data. Here is pretty standard sealed bid auction contract. Only main difference is the bids here is there's a field for encrypted bid. So you can see once we submit an encrypted bid, this amount is filled, and then is decrypted will change later on once we actually reveal the bids using the decryption. Other stuff is sort of fairly standard. You have like a submit encrypted bid function. Here you can see that there are some checks on the conditions. And then these two are all by default false because they're unknown at the start of the auction. This revealed bid function is mainly what's handling the decryption. So what it does is it iterates through all of the encrypted bids. It calls the decryptor contract, which in turn generates the actual underlying values after it's decrypted, and then you're able to use that to populate all the bids and determine who the auction winner is. And then here is just some sort of extra useful functions to have, like issuing refunds for people if they didn't win the auction or anything like that. Okay, I think we have time, so I guess we can just go through like deploying all the contracts one by one. So this is one of the hashing contracts. There's a set of 5, right? So we can go through these together. So these two are mainly for the IBE part, so the hashing and the identity-based or IBE contract. These two are for the symmetric key encryption, and then the final one is like the decryptor interface. And yeah, this part takes a little bit of time because using Stylus, it needs to optimize the size of the contract. So this optimization process takes a bit of time. But it should be fairly quick because I compiled it already. Yeah, and then once this part is done, anyone can deploy these contracts, but also anyone can use them. So you don't have to deploy multiple times. You can just leverage this deployed address already. Yeah, once it's done, we'll go over the actual auction sort of example to interact and deploy like this auction contract. And I think this is the last one, so yeah. We'll just copy this decryptor contract and paste it into our script. And I guess we can go over what the script does. So for the sake of the demo, we generate a master public key, a master secret key. We have some utilities for this for testing purposes, but in a production setting, one can use our network, so the fairy ring chain, to fetch these values. And these would be consistent, and you would also have a set of decentralized validators for aggregating these keys. But for here, we just generate them locally. We set the identity, which is a Stylus workshop, the set of characters, and then we're able to generate the sort of derived secret key. Here is just some conversion functions to convert a hex sort of string to to a byte array. And then we can start deploying the contract here. Eventually, we'll have 2 people make bids, so a bid value of 100 and 150. And then we'll check that the values are indeed still encrypted. And then once the auction has reached the deadline, we'll try decrypting it with the secret key. And then if everything goes well, then we'll see that the auction sort of completes. Okay, yeah, so the contracts have successfully deployed. Let's just check one more time that this address is the same. So then we'll run through this sort of script. So it sort of generated the keys here. This is the same keys in sort of array, byte array format. And now it's just deployed the seal bid auction contract. The first user made a bid, second user made a bid. And now see how highest bid and highest bidder aren't known yet. It's because the auction hasn't finalized. So now we're just checking and waiting for the auction to sort of end. And once it's ended, we'll send the secret key. When was the deadline? Yeah, so 105, right? So it should be here. So we can start sending the key. And successfully decrypted. And now all the decrypted values are like sort of 150 and the winner is determined. Yeah, so that's it for the sort of demo slash workshop. Hopefully, like, it gives you guys a good understanding of how one might use Stylus and actual, like, having on-chain decryption. And yeah, if there's any questions, feel free to find me or ask right now. I think we have some time still.